And this should be working. Hi, hello, welcome to our September edition of our continued education series that we do here at the Ocean Institute for our volunteers. Um, this is always going to be posted going forward to our YouTube page and sent out to you guys on the last Wednesday of every month, like usual. The only thing that's new going forward is that they'll now be posted to YouTube instead of our educational portal, which does mean when you do click the link, we can kind of see who clicks the link, and then you have to email Sophia, Terry, or you could email myself um, in order to kind of redeem your volunteer hours that you do get for watching these trainings. My name is Carly. You've probably met me. I work with Sophia in the volunteer program. We sort of spearhead the department. Um, and today, what I'm hoping we can do is get very, very spooky. It is the last Wednesday of September, which means this training is going to more pertain to October. We have our Spooky Seas event coming up. And of course, we will be needing volunteers for that as well. It's a very fun Halloween event that we do. It's very family friendly. There's a costume contest every year. We do sort of a focus on deep sea, life in the abyss, that kind of thing. So I thought it'd be really fun to dive into the deep sea and talk all about that kind of fun, spooky stuff for the month of October. So we're going to get very, very spooky today. Um, and we can start by taking a look at our agenda. If you do like these extracurricular things, by the way, that get you more volunteer hours, just like this one, you could get volunteer hours for watching this. You can get volunteer hours for attending our Distinguished Speaker Series, which is the first Wednesday of every month. So, the first and the last Wednesday of every month, you can redeem a few hours by learning, which is super fun. The Distinguished Speaker Series is in person, and it is free to our volunteers to attend. So, you guys can all attend for free and listen to an expert in the field talk about something related to marine science or ecology or something related to what it is we do. This month it is going to be Sydney Rylam, and she's talking about marine debris. She specializes in research in microplastics and things like that. So she's going to be talking a bit about her research in marine debris and things like that here at the Ocean Institute. So feel free to come down for that first Wednesday of the month and redeem your free pass to the Distinguished Speaker Series, and you will get hours for that as well. So, diving right into this, we have a few different things we're going to be talking about today. We're going to be talking about what the deep sea is and the challenges that it kind of proposes, and then the adaptations and things that kind of help to combat those challenges. Then we're gonna do a little mini section about creatures and research efforts. It'll kind of be in one slide. We'll kind of highlight a few creatures that have been very recently discovered through research efforts. Um, and you're gonna get to see just how recently, so that we can kind of highlight how new research into the deep sea really is. And we'll talk a bit about how deep sea research is done as well. So, what is the deep sea? The term deep sea, of course, doesn't really have a technical definition. It's like a common colloquial phrase that we use to describe the deeper parts of the ocean. And it doesn't really have a technical definition, but we can kind of start to see where it starts. And that's going to be in the bathypelagic zone. So we can assume anything deeper than 1,000 meters, it's part of the aphotic zone, um, which is an area where sunlight does not reach. So if you think of the word aphotic and you think of the word photosynthesis, or a photograph, things that have to do with light. That word means light. Um, So aphotic means there is no light or lack of light. If you've ever watched any of these before, I will go on and on about the etymology of words, just because I feel like it helps to kind of memorize what that word means if you can break down the word itself. Um, so, aphotic is just no sunlight. And since there's no sunlight, it's going to be constant in temperature because they don't have weather. So there's not going to be a big change in the temperature. It's not going to be like warmer one day, colder one day. It's going to be pretty steady. There's no sunlight, so there's no weather, so there's no change. And that temperature is going to be very, very cold, of course, because there's no light. And that's going to range anywhere between 4 degrees Celsius or 39 degrees Fahrenheit to 1 degree Celsius or 34 degrees Fahrenheit. So not really waters that you would want to swim in. They have very harsh conditions due to the temperature and things like that. They're super under researched. The farthest extent that humans have been is the Mesopelagic zone. So humans have not really even been to the deep sea. Um, and we have done lots of research. We'll talk about how. Um, but this all sort of adds to that mysterious uh, labeled deep sea area. Um, so when we think of the deep sea, try to think of anything below 1,000 meters or below 3,000 feet, because that's about as far as we really know and as far as the sunlight on the surface reaches. And that's when things start to get really weird. So we've got some odd challenges that start to present themselves in these environments. We have food deserts. So there's no sunlight, there's no photosynthesizing organisms, right? Um, which means there's no plants and there's no plankton. Or at least there's no phytoplankton. There's definitely planktons, but phytoplankton, which is a plankton that can photosynthesize, a plankton that only needs sunlight and water to grow, doesn't exist down there. And this is sort of the base of our food chain on the surface of the ocean. Sort of like how plants are part of the base of our food chain on land. So it usually goes sunlight feeds the plants, which feeds the herbivores, which feeds the carnivores. Um, Kind of like a typical food chain. That's going to look very, very different in the deep sea because they don't have that sort of first step that we have. And it gets really, really weird. I'm going to talk about how um, that food chain and that energy source exists down there. Lack of light, they're living in constant darkness. Again, those temperatures aren't ever going to change, they're always going to be very cold. And of course, there's going to be deep sea pressure, right? So the pressure of these zones can be up to 16,000 pounds per square inch. So think of every square inch of your body and then think of 16,000 pounds of pressure being applied to every single inch of your body. Not a place we can easily get to, not somewhere we want to be swimming. Um, it'd be like being pushed by a hydraulic press at every angle. So that's another thing these fish have to kind of adapt to. If you wanted to live in these environments, you would start to kind of have to have to think very differently and behave very differently because this isn't a place that you want to set up home base at necessarily. So we've got a few unique solutions and adaptations to these harsh conditions. And that we're going to start with that food chain. So one of the solutions to this is going to be chemosynthesis. In photosynthesis, right? That word photo again means light. They're synthesizing energy using light. So they take carbon dioxide, they combine it with water, and they combine it with sunlight to create glucose, which is used as an energy source. So bear with me. This gets a little all over the place, a little crazy, but this is not something that can happen in the deep sea. Um, so because we have those aphotic zones where there's no sunlight, we have chemosynthesis. So chemically synthesized energy. This doesn't mean like it's artificial that we're like pumping it down there. It just means that there's these things called hydrothermal vents, and they produce something called hydrogen sulfide, and that, instead of the sunlight, is what's going to combine with the CO2 and the H2O, that carbon dioxide and that water, um, for that same glucose producing effect. It's going to create glucose, it's going to create energy, but instead of that sunlight, we're going to use something called hydrogen sulfide and a few other things that are going to create a chemical reaction. So this is happening in, like I said, something called a hydrothermal vent. Um, and these hydrothermal vents are underground volcanoes, or sorry, under the ocean volcanoes. So magma, right, from the core of the earth, it breaks through the surface sometimes, and that's why we have volcanoes on land. But this also happens under the ocean as well. So magma from the core of the earth is going to break through the surface, but instead of touching air, it touches water. And what's it going to do? It's going to superheat that water very, very fast. That hot water is going to combine with bacteria and dissolve minerals from the rocks around it. It's going to kind of dissolve those rocks up and take those minerals from it. And this is going to result in a chemical reaction that's going to create hydrogen sulfide. And it's going to look like a big plume of steam or smoke under the ocean. Um, so that smoke is full of that hydrogen sulfide. Um, it's going to combine with that CO2 and that H2O in the water, and it's going to create glucose inside the bodies of filter feeding organisms. Just like how sunlight, water, and CO2 is going to create um, glucose inside the structure of plants. Um, this is going to do the exact same, but instead of plants, it's happening inside of these filter feeding organisms, such as these cute little tube worms, which are what are depicted in this picture. And he's saying, I'm converting H2S and CO2 and H2O into glucose. And that's how he's eating. And other things, because of course this is a sessile creature, which means it can't move. If you've ever seen mussels, if you've ever seen tube worms, Pompeii worms, they stick to one rock, they stick to one spot, they don't really move for their whole life. So we call those sessile organisms. They don't move at all, which makes them easy prey. So they are going to hunker down on these hydrothermal vents or very close to these hydrothermal vents so that they can filter feed that that hydrogen sulfide water, and that they can create that glucose in their bodies. Um, and since they can't move, they become easy prey for other things like little crabs, vent crabs, things that can prey on these worms, on these mussels, octopus, deep sea creatures that are coming and kind of picking off these guys who live around these vents. What's really interesting is these vents can stay active, just like volcanoes can stay active for a certain amount of time. These vents can stay active for what they believe to be about 1 to 2 years. So they don't really know how or if these creatures are somehow transporting themselves to other vents after that. Are they moving? Are they migrating? What's happening? A lot of these, of course, like I said, are sessile organisms. They're not going to move. Are they just existing for 2 years? How are they breeding? How are they existing if these vents, these active volcanoes aren't always available to them? So that's one of those interesting mysteries that we're not quite sure about. So if we think about that food chain again, like I said, on land, it starts with the sun, and then we have plants, and then we have the herbivores, the things that eat the plants, and then we have carnivores, the things that eat the herbivores, right? That's kind of the food chain here on land. In the ocean, it's going to look like the phytoplankton, being eaten by like plankton, which are being eaten by jellyfish, which are being eaten by sea turtles, right? It's going to go down the line until like eventually you'll get to sharks or things like that. Um, so down here, that looks a little different. So instead of the sun, we have these hydrothermal vents. Instead of plants, we've got these sessile creatures, these tube worms, these mussels. They're sort of like the quote unquote plants, the producers of our food chain down here. Then we've got things like the crustaceans and the octopus and things that are feeding on these sessile organisms. Then, of course, there are probably bigger things in the deep sea that are feeding on those smaller things, and it keeps going up and so on and so forth. So, very different than photosynthesis, but really it's just a few extra steps. Um, and that's kind of how, if anybody ever wonders how do they have an existing system down there if there is no sunlight. This is how they're starting their food chain. So they do have a food chain. In addition to that, we have one other way that they're really getting mass amounts of food in this food desert landscape. Like I said, um, there's not a lot of food down here. Um, and that's because of things like these hydrothermal vents. There's not an abundance of things that are um, feeding off of sunlight or feeding off of creatures living in sunlight, which means when we have food float down from the surface, as in whale falls, that is a very valuable thing for them. So we have something called a whale fall, and that's when a whale dies and it sinks to the bottom of the ocean, right? And when that happens, we have a few different stages. We've got our first stages are going to be creatures eating on the flesh and the meat of these things. Um, they're going to start to break down this body. It's like an old country buffet for sea creatures down there. They are living for this. This is like the hottest, newest restaurant just opened up in town, and everybody's got to go try it. Because, of course, if you're a creature that is going a long time without food, your metabolism is going to be adjusted to that. But when you see that food, you're going to be all over it. So everybody's lined up to try the hottest, newest whale fall in town. They're going to eat from this whale. Um, and then we have the opportunist stage, which are little things that are going to start to grow on those bones and take nutrients from those bones, things that other things can't usually consume or eat. That calcium, the marrow, things like that are going to be preyed upon by things like polychaete worms and teeny tiny hooded shrimps and things that can start to kind of grow, again, sessile things that are going to grow on these bones, fan worms, things that are going to take refuge here. Really, not only is this going to become the hottest, newest restaurant in town, then it's going to become the hottest, newest real estate in town, because all these little creatures are going to move in. And as it starts to break down, you're going to have these anaerobic bacterias that are kind of being produced from it and moving into it, and that's going to create more food source, and it's going to completely break down these whale falls eventually. So this is an exciting thing that happens for them down there. This is the highlight of your time in the deep sea, is going to be when that next whale fall comes, which is why it's not a great thing when we have whales wash up on shore or anything like that. Of course, it's something that happens and we have to take note of why, or we could use them for research or things like that. But we want those things to stay in the ocean because that's still part of that cycle. Even after they've died, they're, like it says here, the gift that keeps on giving. They're still part of that circle of life. They're going to continue to be a part of that circle of life. Um, and they're going to aid other animals, which honestly, this is the most spooky gothic thing that can be happening in the ocean. It's very amazing. Here's a real picture of whale fall. This was taken, I believe, from the Nautilus, which is a deep sea research group. We'll talk a bit about how they're getting this kind of footage later. I'm sure you guys have an inkling of that, but we can see here a couple deep sea octopus. I believe they're called Casper octopus. And then some kind of a long snailfish or an eel, some lampreys. They are taking over that skeleton. That white stuff you see is called a bacteria mat. And that is something that will take over part of the anaerobic stage. These bacteria mats are kind of feasting as well on whatever is left. Eventually, like we saw before, this entire thing can and will be used for homes and then eventually decomposed entirely. So this is the coolest, spookiest thing that's happening in the deep sea, in my opinion. Is super awesome. All these species, these are like research hubs. If you can find a whale fall, you can find all these species that you can research and how they are feeding and what's feeding on these whales and all this stuff that, again, we don't quite know a lot about the deep sea yet. It's exciting to see. So it's good to have these kinds of things we can look for. All right, we are going to talk a bit about physical adaptations. Um, which is of course tying into how are we surviving this deep sea and its challenges, in addition to how they're feeding or what the environment is presenting for them. There are physical adaptations that they are presenting to adjust to their environment, right? And adaptation happens over time. It's part of evolution. It's going to change elements of an animal's body. It can be a body shape, defense mechanism, patterns, other features about it. Everything that they have is an adaptation, right? Adaptations are part of that evolutionary process, and then they're going to fit the survival needs of the organism. So, since there are some very harsh conditions in the deep sea, and they're not conditions we're used to seeing anywhere near on land or on the surface of the ocean, it just means we're going to start seeing adaptations um, that we aren't used to seeing. I think that says are used to seeing here, but what I meant to say is we're going to start seeing adaptations that we are not used to seeing. So everybody thinks of creatures who live in the deep sea as a little bit creepy, a little bit spooky. That's just because they're dealing with environments that are so different from our own that they've had to adapt to those environments, and they just look very different than what we're used to seeing. It doesn't necessarily mean that they're really truly terrifying creatures. They're just adapted to whatever they have been dealt with. And one of those physical adaptations is going to be bioluminescence. So this is a really cool one. We talk about it on our bioluminescent night cruises when we go out and see those bioluminescent waves. Um, and we also talk about it a lot during spooky seas. We talked about a lot, I think, during Sharks After Dark. So it's definitely something that we also talk about in our programs here at the Ocean Institute. Bioluminescence is the ability of an organism to emit light through a symbiotic bacterial reaction in their bodies. So the thing that's creating the light is bacterias. Bacteria exist in pretty much everything, right? You've probably read the label of yogurt and seen that it says something about the probiotic bacteria that are inside of it. Those are good bacteria. They're not bad or scary or anything like that. We have bacteria that live in our gut, right? We've probably heard that before. You have a microbiome in your gut, in your body. Um, so there are bacterias that live inside of us, and they're supposed to be there. These animals have them too. The only difference is these ones emit light. So they've got bacteria in their bodies that can emit these lights. It would be really cool if the bacteria in our bodies did that, but unfortunately they don't. They just help us digest food. Um, but with these guys, we tend to think of it as maybe some sort of a chemical reaction, but we have to kind of remember like that again. You'll hear me talk about etymology a lot. Bioluminescence as opposed to chemoluminescence, which is a thing. Chemoluminescence is going to be a chemical reaction causing light. Sort of like what you see when you crack a glow stick and it starts glowing. That's a chemical reaction. That's chemoluminescence. Um, Bioluminescence is going to have that root word bio, which means something living, and that living thing, of course, being bacteria. So that's kind of how you can tell the difference. It's not some sort of chemical reaction, it's a living reaction. Um, and so we have species like anglerfish that are going to use this to attract prey in darkness, some that are going to produce lights from their underside to kind of try to counter shade or match the light coming from above them. It can be used for mating and communication. It can be used to help species find each other. There is a species of shrimp, I believe, or squid in the deep sea, and they spray bioluminescent goo everywhere, kind of like how octopus will ink. They'll do the same thing with a bioluminescent goo to their predators. So that way they can run away, but their predators are stuck glowing in the dark, which is not something you want to be doing in this deep, deep sea. So they've made their predators more vulnerable to other predators, which is very, very interesting to me. Um, we have lots of jellyfish that light up, lots of things that we're not quite sure about the purpose of their bioluminescence yet. If you've ever seen our swell sharks, I'm sure you have. We have our swell sharks. They um, used to be little babies living in Somme. Now they're living in, there's a few in the large tank farm in Assi. And there's a few in the new estuary exhibit. Those guys bioluminesce. We can't see it with our naked eye. Um, but they do bioluminesce. You can see it under very intense black light. You can see it with specialized lenses, which is how scientists found out that they do that. It was a fairly recent discovery that those sharks do that. And they're not super deep sea species or anything, but there are lots of things that bioluminesce in the ocean. And they're not sure why those swell sharks bioluminesce. Is it to find each other? Is it um, for a different reason? They're not quite sure. So again, there's lots of things in the deep sea we're not sure about. We have a couple confirmed reasons why things are bioluminescing, but still lots of stuff that we're not sure about. Which, by the way, this is kind of off topic, but if you've ever wondered about our bioluminescent night cruises, what's making those waves like that? It's algae. It's bioluminescent algae that is growing on the surface of the water. And it's not the cleanest, safest algae to be swimming around in. It's super cool to see from a boat, but if you are witnessing a like bioluminescent wave event, super cool to watch from the shoreline. I wouldn't really recommend getting in there. You see lots of cool videos online of people being like, "Oh my gosh, we saw bioluminescence and we got in there and we splashed around. It was super cool." It is super cool. And maybe worth the risk, but it is also kind of not the cleanest water. So take that as you will. Maybe jump in the bioluminescence, maybe don't. It is algae, but it's not necessarily indicative of a clean ocean. Uh, but I digress. The next one we're going to talk about is disproportions. Disproportions are when you start to see parts of the body that are very, very bigger in comparison to the rest of the body, much smaller, things like that. So we've got some deep sea fish, excuse me, that have, sorry, some deep sea fish that have disproportionately large mouths and jaws and teeth that can be like a lot larger than the rest of its body in ratio, might seem a little odd. But living in an environment where food is scarce, having a large mouth allows creatures like fangtooths or gulper eels to eat prey of varying sizes whenever they find it. So it's kind of like saying I can't be picky with what I'm gonna eat. I'm not sure when I'll find food next. Like I said, these creatures do have really good metabolisms, meaning that they can eat far and few between. They can go like months without food. It's all about conserving energy. But it also means when you find food, you want to get food. So they've got these really disproportionate mouths. They've got extendable bellies, which is what a lot of anglerfish do. Their stomachs can just extend just in case they come across something and they're like, I don't know when my next meal will be, but this thing is much larger than me. We're going to try to eat it anyways. So we also have species like anglerfish with their expandable stomachs, like I said, things that are trying to consume prey whole. Another thing with those large teeth is to kind of trap something, as much as it is to puncture things. It's also to keep something in their mouth once they've got it so that it can't really escape. So that is disproportions. You'll also start to see this. I guess we'll talk about it on the next page, but on the next page, we were talking about specialized eyes and senses. Specialized eyes can go in with that disproportion because once you get to certain parts of the ocean, almost all the fish you'll start to see will have very, very disproportionately large eyes. Um, so you'll start to see things that either have no eyes or very large eyes so they can consume as much light as they can into those eyes, into their retinas, and that they can um, sort of see in the dark or see as much as they possibly can at least. Um, so, like I said, the eyes of these deep sea organisms, they could be reduced in size, they could be highly specialized, like very large, or they could be completely absent. We'll start to see a lot of things that are blind down here as well. Large eyes or sensitivity to light are common in species like hatchetfish, which have upward facing eyes to detect their prey from above. Not only is that going to give them an upper hand in ambushing, but it also means that they can pull in a little bit more of that light that's happening above them. Creatures like the Dumbo octopus, they're going to rely on other senses like touch and detecting vibrations, things that are completely blind. We're going to also see some animals when we get to elongated body that have what they call feelers. So they're fish with little feelers. And they're using those more than they're using their eyes. They're kind of feeling around their environment. Um, and then, like we said earlier, there's a lot of deep sea pressure. So, another physical adaptation you're going to see is everything is going to be very pressure resistant. Um, so, we have things like tube worms. They're flexible, they're worms, they're um, soft bodied. You're going to see things like big red jellyfish. They're very gelatinous. You see lots of jellyfish species down here. Um, a lot of jellyfish species down here, actually. And that's because they can survive these pressures. So they have a better chance of adapting and creating more species of themselves. If we remember the picture that we saw of the whale fall, there were some octopus on there. There were a few like long, smooth fish. These guys all look a little bit similar in that they all look very soft and squishy. We do have some fish species that aren't like that, but they typically um, have things like internally that help them to stay both regulated and depressurized. Uh, these guys can withstand a lot, which is why it's incredibly hard. This deep sea pressure is part of what helps that metabolism that they have and helps them to be able to go um, very long periods without food. Which is why when we try to research these things, it's not always easy or it's not always going to work to pull them up from the deep sea so that we can research them on the surface. Once you pull them out of that very, very pressurized zone, unless you're very, very particular with keeping them under pressure and storing them somewhere very pressurized while you're doing research with them, typically they're not going to survive because they're used to that pressure. It's going to give them metabolic issues. They're not going to be able to eat properly. And their bodies are kind of relying on that pressure to keep their form. We'll talk a bit about that when we talk in a minute about our creature feature that we have. But we're going to talk a little bit more about these elongated bodies that I mentioned before, the fish that we have. Um, You can see in the upper corner on the dragonfish, those feelers that I was talking about. You see these very long, long little fins that are coming off of them. These are kind of helping them to feel around, to sense around. None of these guys have eyes that are particularly great at seeing or good for that function. So we have these really streamlined bodies with long, long appendages or feelers. Um, we have tripod fish. They're very long, they're very slender. It helps them sense their environment. And that tripod helps them to stabilize themselves on the ocean floor. Uh, You've probably seen them before. They've got these very, very long fins, and they just use those fins like little legs, like a tripod, exactly, to just sit on the ocean floor and not move. This is a method of conserving energy. They don't have to swim. They're not hunting prey at the moment. They're conserving their energy because they need to. Like I said, those metabolisms, they're not finding food very often. Therefore, they need to be conserving as much energy as possible, or else the more they're moving around, the more they're hunting, the more they're expending that energy, the more they're going to need to eat. So it's in their favor that they are very chill, just sitting on the ocean floor. They don't have to swim. Um, and then there's things like viperfish, which have those long bodies that help them kind of navigate through the dark, through open waters. A lot of fish with long bodies also have lateral lines, which helps them sense little tiny bits of movement and vibrations in the water. Um, so that's a lot of the physical adaptations that are used in the deep sea. The last thing we're going to kind of take a look at is we are going to talk about some of the most recent discoveries we have. Not most recent discoveries, but a few new recent discoveries, just to kind of highlight just how under researched this part of the ocean is, that we have so many new species that are coming up very recently. We have the bumpy snailfish. This was found off of Monterey. It was actually observed off of Monterey on camera in 2019, but it wasn't until August of 2025, this year, that we were able to get enough recording of it, enough data to realize, yes, this is an entirely new species. We weren't sure before. There's a lot of species in the ocean. You got to check every book, make sure this isn't something somebody already discovered before you go, I discovered this thing, and somebody's like, nope, that's already been found. So when this was discovered, it took them a while to kind of, you can't base it off of just one recording. They had to get a lot more data on it. So it was just this year that it was quote unquote discovered, that it was added as a new species. The bumpy snailfish. Very, very cute. Um, and then we have the scarlet crown jelly. It was found in 2022 off, I want to say, the coast of Palo Alto, up in the Bay Area. Um, and again, a lot of the species you're going to see down there are jellyfish. This was a new one. They had never seen anything like it before. Um, and then we have the sea toad. Very funny looking guy. He's a little fish with legs. They called him a walking fish as well, because if you take a look below him, he's got these two little legs that he uses to kind of waddle his way through the seafloor. Very interesting creature. He was found in 2024, just last year. I believe also off the coast of Monterey. I could be switching one of those around. But I believe he was all of these creatures were found up in near the Bay Area. Um so how are they actually recording these creatures? How are they finding these things? Of course, we can't send people down there. If you've ever seen research expeditions where they are in a submarine, they're probably not quite as deep as these deep, deep abyssal zones, these deep, deep hadal zones, right? Um, So what they're using is an underwater drone, essentially, an ROV, which stands for remote operated vehicle. It is like a little submarine that you do not need to be in. You can control it with a remote on land. There are a few advantages to this, some of them being the fact that you don't have to put a person in harm's way. If something breaks, I mean, it's terrible because they are expensive devices, but again, it's better that a robot breaks than a human. Um, and you can do a lot more because they can withstand a lot more pressure. They're also not quite as invasive as a full size submarine would be, because you can make these things really, really tiny. So you can send these things down there with special lights. A lot of these creatures can't see certain lights. A lot of these creatures can't see the color red, because that's the first to go when sunlight starts getting dispersed. The color red is going to start disappearing as you get further and further down there. Which is why you'll see a lot of these creatures that you're looking at have like a pinkish reddish tone. Their predators can't see that color. So it makes them have a little bit more of an advantage in blending in. There are also, just a little bit of a digression, but on the topic of red in the deep sea, there are certain species that are fixed with these red bioluminescent lights on them that they use sort of like a headlight. So they've got this bioluminescent red light that they can emit to help them see things around them. But since most other creatures in the deep sea can't see that color, they're not even going to realize that there's a spotlight being shined on them and that they're being hunted. It's really, really fascinating. So they can fix these red lights on them and view them without them even realizing they're being viewed. Um, so there's a lot we can do with ROVs that we couldn't really do without scaring a lot of creatures away. And that's how a lot of this research has been found. Like I said, that picture of that whale fall was from the Nautilus. It's a deep sea research expedition that is ongoing, and they utilize those ROVs like that. You might have seen the videos of them. It's a lot of voiceovers from the scientists speaking as they are exploring. They're not talking to each other in a submarine. They are talking to each other on land while recording with an ROV. So they're super, super useful tools. I don't think we need to send any more people down there. We have the technology not to. So there are limitations to it, of course. One being it's an expensive technology. Another one being it's very finicky, especially when it comes to those deep sea pressures and how they are made, what they can withstand, um, and things like um, distance in footage being sent back up to whichever entities are trying to review it in real time. uh, Chords can be issues, things like that. There are things that are limitations for these. Excuse me. Sorry. There are some things that are limitations for these devices. But overall, there's pros and cons to everything. It is the only form of research we really effectively, consistently have right now in the deep sea, which is super, super awesome. Another thing I wanted to just highlight while we're talking about these creatures, while we have this little creature feature up, is the blobfish. You may have seen this little guy around. They make children's stuffed animals out of him. They make t-shirts and logos with this blobfish on it. It was voted like the ugliest animal at some points. Because usually what we see is this pink, fleshy, little frowny faced design of them. Uh, because that was originally what the public's perception of them was. That was how they were shown to people, that was what they looked like. What a lot of people didn't realize was that is what they look like when they've been depressurized. They're a creature that relies on pressure. When you pull them up from the deep sea, they've got this frowny, saggy face and wrinkles and this droopy, what would appear to be a nose. When they're under the water, they just look like these cute little guys. They just look like little fish. They're not actually saggy and floppy and funny looking. They look like that when they've been depressurized because their body is using that pressure to keep its form. You pull them out of that depressurized zone, they just get kind of sad and saggy. So blobfish, I just wanted to highlight them because again, this is all knowledge you can use throughout October as you might be getting more questions about spooky things in the sea and deep sea things like that. You could mention that this little fish, he's not actually as funny looking and as quote unquote ugly looking. I think he's cute in both ways, but this quote unquote ugly looking fish, that's not actually what they look like. He's just a deep sea creature that uh has been taken out of his deep sea zone. Um so yeah, that's kind of my spiel on the deep sea. Like I said, please join us for our Spooky Seas event. It's going to be awesome. It's going to be great. I'm very excited for it. We're going to get to highlight some of this fun deep sea stuff. So I hope some of this deep sea knowledge can help you guys out. We went over a lot of adaptations in this one. I've said it before and I will say it again. If you can figure out why something is shaped like that, why something has that feature, what reason it could have evolutionarily to look like that, be like that, you can learn about a fish just by looking at it. So, any fish, any creature you see, somebody has a question about some deep sea creature, you're not quite sure how to answer it, try to think in terms of, well, maybe I'm not quite sure what this fish is, but I can point out some adaptations that it has that have to serve it a purpose, because every adaptation has to serve a purpose. None of these adaptations have evolved onto them for no reason. Every adaptation they have, they've evolved for the purpose of survival. So try to think of every animal kind of critically in terms of, why does it have that? Why is it shaped like that? I'm gonna go back actually and take a look at these guys we have so we can think of those examples. That bumpy snailfish, he's got these two little beard hairs that hang down really long, and really long little things sticking off of him, of his fins. These very long little fin tassels, I guess you could call them. And very, very bumpy, rigid skin. Uh, and I don't know quite a ton about this snailfish as it is, but I can already see those um I can see those adaptations in him, and I can tell myself, well, when creatures have that adaptation, what is it for? And in the deep sea, it's for feelers. They're usually feelers, and it's for navigating without eyesight. He probably doesn't have great eyesight down there, and he's relying on those feelers to get around. Again, like I said earlier, with that scarlet jelly and that sea toad, um, why are they red like that? It's probably because creatures in the deep sea don't see the color red, right? Like I can go and look into this stuff, but now that I know a lot about what they have to survive and what adaptations exist down there and what adaptations, are, I know that each and every single thing about these creatures serves a purpose. It's just a matter of figuring out what it is. The jelly, it's got these long tentacles. I can assume that they're for stinging, they're for feeling, and they're for feeding. Its body is gelatinous. I can assume because it is going to make it easier to survive in the deep sea, being pressure resistant. Um, Things like that. Just things to keep in mind if you're ever unsure about a creature or what it is. Try to think of it in terms of, that's not some ugly, horrifying creature. That's just a creature that has been adapted this way for a specific reason. I wonder how many adaptations can I point out and see in them. Uh, so if you did like this video, again, consider joining us for our Spooky Seas, and consider joining us for October's Distinguished Speaker Series to get more extracurricular hours. I just realized that is spelled wrong. Ignore how it says extracurricular on the screen. But join us to get more extracurricular hours while learning new things at our Distinguished Speaker Series. Like I said, we'll be talking about microplastics in the ocean, and truly, 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 nothing in this video could possibly be any scarier at all than the real horror that is microplastics in the ocean. I mean, come on now. So that's going to be absolutely terrifying, I assume. So you should all join us if you're interested in some very, very spooky facts about pollution in the ocean. And I'm sure it won't all be doom and gloom, because Sydney Ryland's been working really hard on ways to combat this as well. So I hope to see you guys there. Remember, you guys get in free for that. And remember, you can email Sophia to claim your volunteer hours for this training. You could email me. You could email our volunteers email at volunteers@oceaninstitute.org. Thank you so much for watching, and thank you for always looking for more opportunities to learn and to help be ocean stewards and to help out our facility. We are very very grateful. And if you do have any questions or you want more resources or anything that was mentioned in this was unclear to you, you want clarification, anything like that, feel free to email me as well, right? klopez@oceaninstitute.org. I'm the volunteer specialist, and I am always happy to help out as well. So, thank you guys so much for tuning in, and I will hopefully be able to see you guys soon, and we will have another one of these videos for you at the end of October, last week, Wednesday in October. Uh, Thanks, guys. Have a nice day.